National Electrical Code Article 300 provides general requirements for wiring and raceways, including conduit support. ANSI C2, the standard for the National Electrical Safety Code, provides specific requirements for the installation and maintenance of overhead electrical supply and communication lines. Websites and catalogs of manufacturers such as Conduit, Legrand, and Hubble provide information on the load capacities of their EMT support systems. The NEC Handbook provides detailed commentary and explanations of NEC requirements, including those for conduit support. Electrician Toolbox is a website that offers resources and information on electrical topics, including EMT support systems. Electrical Answers is a forum where questions can be asked and answers can be received from licensed electricians. The following table provides general guidelines for EMT sizes and quantities that can be supported by a suspension wire. For 1/2-inch EMT, the maximum weight per support is 15 pounds and the maximum number of vertical supports per 100 feet is 3. For 3/4-inch EMT, the maximum weight per support is 25 pounds and the maximum number of vertical supports per 100 feet is 2. For 1-inch EMT, the maximum weight per support is 40 pounds and the maximum number of vertical supports per 100 feet is 1.5. For 1 and 1/4-inch EMT, the maximum weight per support is 60 pounds and the maximum number of vertical supports per 100 feet is 1. For 1 and 1/2-inch EMT, the maximum weight per support is 80 pounds and the maximum number of vertical supports per 100 feet is 0.75. Additional considerations include the weight of the conduit and other fixtures supported by the wire. The span between supports should be limited to manufacturer recommendations. The suspension wire should be properly tensioned to prevent excessive sag. The type of wire and fittings used should be appropriate for the intended application. These guidelines are for general reference only and should not be used as a substitute for consulting with a licensed electrician or qualified professional. When installing electrical conduit, it's crucial to adhere to industry standards and codes to ensure safety and compliance. The National Electrical Code, or NEC, is a primary source for general requirements for wiring and raceways, including conduit support. Article 300 within the NEC provides specific guidance on this topic. In addition to the NEC, the National Electrical Safety Code, or NESC, also known as ANSI C2, offers specific requirements for the installation and maintenance of overhead electrical supply and communication lines. This standard is particularly relevant when dealing with suspended conduit systems. Manufacturers of conduit fittings and supports, such as Conduit, Legrand, and Hubble, provide valuable information on the load capacities of their EMT support systems. Their websites and catalogs are excellent resources for product specifications and application guidelines. The NEC Handbook offers detailed commentary and explanations of NEC requirements, which can be particularly helpful for understanding the nuances of conduit support. Online resources like Electrician Toolbox provide additional information on electrical topics, including EMT support systems. These platforms often offer practical tips and best practices for installation. Online forums such as Electrical Answers provide a space to ask questions and receive answers from licensed electricians, offering a valuable opportunity to gain insights from experienced professionals. When considering the specifics of EMT sizes and quantities that can be supported by a suspension wire, the following guidelines can be helpful. These are general recommendations and should be verified with local codes and manufacturer specifications. For 1/2-inch EMT, a maximum weight per support of 15 pounds is generally recommended, with a maximum of 3 vertical supports per 100 feet. For 3/4-inch EMT, the maximum weight per support is typically 25 pounds, and the maximum number of vertical supports per 100 feet should not exceed 2. For 1-inch EMT, aim for maximum weight per support of 40 pounds, and limit the number of vertical supports to 1.5 per 100 feet. For 1 and 1/4-inch EMT, a maximum weight per support of 60 pounds is generally acceptable, with a maximum of 1 vertical support per 100 feet. When using 1 and 1/2-inch EMT, the maximum weight per support should be around 80 pounds, and the number of vertical supports should not exceed 0.75 per 100 feet. Several additional considerations should be taken into account. Firstly, the total weight of the conduit, including any wires or cables it contains, along with any other fixtures supported by the wire, must be considered. Secondly, the span between supports should adhere to the manufacturer's recommendations to prevent excessive sagging or stress on the conduit and supports. Thirdly, the suspension wire should be properly tensioned during installation to minimize sag and ensure adequate support. Finally, the type of wire and fittings used must be appropriate for the specific application and environment to prevent corrosion or failure. Always remember that these guidelines are for general reference only. They should not be used as a substitute for consulting with a licensed electrician or a qualified professional who can assess the specific requirements of the installation and ensure compliance with all applicable codes and regulations. When calculating the allowable weight on a suspension wire, consider not only the weight of the conduit itself, but also the weight of the conductors inside. Copper conductors are heavier than aluminum, so the choice of conductor material will affect the total weight. Also, take into account any boxes, fittings, or other devices that are supported by the same suspension system. Proper spacing of supports is critical to prevent sagging and to distribute the load evenly. Consult manufacturer specifications for recommended support spacing for the specific type and size of EMT being used. In addition to wire suspension, other methods of supporting EMT include using clamps, straps, and hangers. The choice of support method will depend on the specific application and the available mounting surfaces. When using wire suspension, be sure to use the correct type and size of wire. Galvanized steel wire is commonly used for this purpose, but other materials such as stainless steel may be necessary in corrosive environments. The wire should be securely fastened to the conduit and to the supporting structure. Use appropriate fittings and hardware to ensure a strong and reliable connection. When installing EMT in a wet or damp location, use watertight fittings and supports to prevent corrosion. Consider using PVC-coated EMT for added protection in highly corrosive environments. Proper grounding is essential for electrical safety. Make sure that the EMT system is properly grounded in accordance with the NEC. Use appropriate grounding fittings and conductors to ensure a low impedance path to ground. When installing EMT in a hazardous location, follow the requirements of NEC Article 500 and choose appropriate explosion-proof fittings and enclosures. Regular inspection and maintenance of EMT systems are important to identify and correct any problems before they become safety hazards. Check for signs of corrosion, damage, or loose connections. The information provided offers general guidelines. Always consult local codes, manufacturer specifications, and qualified professionals for specific applications. Electrical work can be dangerous, so it is important to take all necessary precautions to protect yourself and others. Wear appropriate personal protective equipment, such as safety glasses, gloves, and a hard hat. Work in a well-lit area and avoid distractions. If you are not comfortable performing electrical work, hire a qualified electrician. The NEC is updated every 3 years, so it is important to stay current with the latest requirements. Consider subscribing to an electrical trade magazine or attending continuing education courses to stay informed about changes in the industry. Many online resources are available for electricians, including websites, forums, and online training courses. Take advantage of these resources to expand your knowledge and skills. The electrical industry is constantly evolving, with new technologies and techniques being developed all the time. By staying informed and continuously learning, you can ensure that you are providing the safest and most efficient electrical services possible. Consider the ambient temperature when determining the allowable weight on a suspension wire. High temperatures can reduce the strength of the wire, so it may be necessary to reduce the allowable weight in hot environments. The NEC provides tables and guidelines for adjusting ampacity based on ambient temperature. When running EMT through walls or floors, use sleeves or bushings to protect the conduit from abrasion. This is especially important when running EMT through concrete or masonry walls. Proper labeling of EMT systems is important for identification and maintenance. Use labels to identify the circuits and equipment served by the conduit. This will make it easier to troubleshoot problems and perform maintenance in the future. When bending EMT, use a conduit bender to avoid kinking or damaging the conduit. Follow the manufacturer's instructions for using the bender. Avoid overbending the conduit, as this can weaken it. When cutting EMT, use a hacksaw or a pipe cutter. Deburr the cut end of the conduit to remove any sharp edges. This will protect the conductors from damage when they are pulled through the conduit. When joining sections of EMT, use couplings and connectors that are listed for use with EMT. Tighten the couplings and connectors securely to ensure good electrical connection. Avoid using dissimilar metals in an EMT system, as this can lead to corrosion. For example, do not use steel couplings with aluminum conduit. When supporting EMT from a ceiling, use trapeze hangers or other suitable supports. The support should be spaced according to the manufacturer's recommendations. When running EMT parallel to structural members, maintain a minimum clearance of 1/4 inch to prevent contact. This will help to prevent corrosion and damage to the conduit. When running EMT in a concealed location, such as above a ceiling or behind a wall, be sure to comply with the requirements of NEC Article 320. This article covers the installation of concealed wiring methods. When installing EMT in a healthcare facility, follow the requirements of NEC Article 517. This article covers the special requirements for electrical installations in healthcare facilities. When installing EMT in an industrial facility, follow the requirements of NEC Article 670. This article covers the special requirements for electrical installations in industrial facilities. Proper planning is essential for a successful EMT installation. Before starting the installation, develop a detailed plan that includes the location of the conduit, the type of supports to be used, and the size and type of conductors to be installed. This will help to ensure that the installation is done safely and efficiently. Effective communication is essential for a successful EMT installation. Communicate with other trades, such as carpenters and plumbers, to coordinate the installation and avoid conflicts. This will help to ensure that the installation is done on time and within budget. Documentation is essential for a successful EMT installation. Keep accurate records of the installation, including the location of the conduit, the type of supports used, and the size and type of conductors installed. This will be helpful for future maintenance and repairs. The information given is intended as a general overview and is not a substitute for professional advice. Consult with a qualified electrician or engineer for specific recommendations related to an EMT installation project.